G'day, good evening. Hope you're well. Thanks for listening. This is an agricultural and horticultural show focusing on plant science, soil science and microbiology. And the information provided is fact-checked, and any of the papers or websites that are discussed will be put in the description below. And today is going to be excellent again because it's on farming for sustainable agricultural production. It's a course that I did quite a few years ago, but it's just so relevant, so on point, and so cool. So I thought that's what we're going to go through again today. We're up to lecture 10. So it's lecture 10 to 20. I think I put in the title. We'll see how we go because it's a lecture. It's compost and vermicastings. And there's stacks to go through on that. Just in those two alone, which is about 5 lectures, there's probably going to be enough content for an hour. Because and also I'll go into detail too about different things that I can add. So I'll wait for a few to arrive, give another 40 seconds. Like 420 Fred says hello. Hello. That's Jeffro. Says morning, afternoon to everybody. I'm looking forward to today's video. Thank you for the nice words. Genetic Memory Farm says good evening, good peeps. I hope you all are safe and happy. Very nice. So yeah, it's going to be great today. Compost and vermicastings. 5 lectures on it. I don't even think we're going to get through that many. Well, actually, yeah, we're going to get through 5. Let's start. Well, for those who are, I adjusted I'll talk about the logo a bit later. I adjusted it a bit. Let's get onto it. Share screen, straight into it. Allow lecture 11, because we did lecture 10, yeah, because it was 11. What's compost? So this is on this course. There's the course, Organic Farming for Sustainable Agricultural Production. I study in India at different universities there, and it's so bloomin' rad. They're really into organics because of their massive population, highest in the world. They've got to do something. So they're trying to fix up the lands, and I love the literature. So what's compost? Compost is an organic matter that has been decomposed and recycled as a fertilizer and soil amendment. Compost is the key ingredient in organic farming. And I'm not going to read I'll summarize. I'm not going to read every single bit of all of these slides because it'll take too long. So I'm just going to skim over the bits that I think that are relevant. And if you wish to pause, if you wish to read more, you'll have to press the pause button or watch it later on. The end product of decomposition is organic matter, which is rich in nutrients. It acts as a soil conditioner, fertilizer. It's a vital humus or humic acids, and as a natural pesticide for soil. Compost is called the gardener's gold because it is an invaluable partner in keeping the soil healthy. What's humus? Humus is a complex mixture of dark brown, amorphous, and colloidal substances modified from the organic plant tissue or synthesized by various soil organisms and is resistant to microbial decomposition. It's really soil. The humus is the end product of compost. It's all of the dark humic acid. Well, there's 3 parts: the humin, humic acid, and fulvic acid make up humus. And the I won't go and read what this says first, then I can elaborate. If it doesn't cover it, it's probably a better option. Properties of soil humus. Humus particles are bonded to clay and other silicate surfaces, leading to the formation of soil humus. It's got many nutrients. It absorbs pesticides and other agricultural chemicals too. What's composting? Composting is a natural biological process carried out under controlled aerobic conditions, requires oxygen. You can do it in anaerobic, but it's sort of, it doesn't have a good end result, and it uses up all of the oxygen first. So your nitric NO2 and NO3 that's been produced will get used up as well. So it's not really a good, so you can do it, but it just doesn't give you the composition that you want. I've done it, and it turns out really, really dark, mega dark humic acid type of soil. It looks fantastic, very water retentive, but it's lacking in certain nutrients. So what's composting? Well, the breaking down of organic matter into simpler substances by bacteria and fungi. I'm not going to go into that detail. Types of composting: aerobic, anaerobic, oh yeah, there it goes, and vermicomposting. So aerobic is quickly to break down because it uses oxygen and temperature. Anaerobic takes a lot more time to break down, needs less maintenance since it's in a closed environment, not allowing oxygen, and releases some gases, ammonia, and CH4 is methane, I think. Ethylene, methane. Vermicomposting uses worms. Earthworms are the workers, and it's done in oxygen, moisture-rich environment. One good thing about using earthworms is they secrete ammonium and H4 on the outsides of their skin. My teacher in one of these classes was a worm biologist. She just focused on that. Principles of composting. Well, you're right, got to get the right carbon-nitrogen ratio. Otherwise, it'll break down too fast and not retain nitrogen, or break down too slow and not give you a result you want. Mixture of organic materials, size of residue, moisture and temperature, pH. Well, yeah, microorganisms and microbial inoculants are very important because they're the bits that do all the work for you. And amendments if you want to put in. Look at the little shredder. That's pretty good. So I get, because India isn't very rich, they teach you the cheap way to do things, and then I call it the USA way to do things. If you've got money, you can just go and buy a machine to do it. And look how cheap this is. Shredding of waste materials. That is just excellent. Little tiny, that's just, I like it. I like the little simple ways. So the principles of composting: carbon and nitrogen ratio of input residues. So I'll see if there's any questions. This is right up for you, Genetic Memory Farms. You asked about the ratios a while ago, I remember. And it looks like we're just going to get on to the ratios. So that's going to be good. No questions. Back to it. What was I doing again? Here we go. So the carbon to nitrogen ratio of input residues. Microorganisms require carbon for growth and nitrogen for protein synthesis. Carbon to nitrogen ratio of 30 to 40 is optimal for composting. It's a little bit lower than that. If the material has a high carbon to nitrogen ratio above 40, it takes longer, and below 20, I'd say, the nitrogen is used up by microbes, and it happens very fast, but you don't get a good end result. So you want it, it's about 20 to 30 to 1. So sorry, carbon of 20 to 30 to a ratio of 1 to nitrogen. And microbes are 24 to 1 is their requirement. Grass clippings are 25 to 1, or alfalfa 25 to 1, which is perfect. So just use your grass clippings as a suggestion, then put your other stuff in with that, your food scraps and that sort of thing. And one reason why you bury your green material, your green manure it's called, is because it volatiles off. You lose 20 to 40% nitrogen is lost through ammonium. Oh, that's in water, hyacinth, animal dung, and immature green organic materials. But if it's not buried, it turns brown, and then that brown has lost all its nitrogen, and that means that the NH3 is gone back to the atmosphere. So you want to retain that, so that's why you bury it. Mixing of organic materials. What's that? Mix or having a high carbon-to-nitrogen ratio can be mixed with, I'm not going to go into that much detail, principles of composting, because there's so many different techniques to do it. It's really the carbon to nitrogen, the things you want, carbon to nitrogen ratio, moisture and temperature is pretty much it. Then you've got to get the right technique to allow the process to happen. And then you've got to, all your inputs that you got, they've got to be sourced from the right areas. If they've got antimicrobials in them, they got glyphosate, for instance, which is an antimicrobial. It's not going to work to what you want. So principles, back to this. Size of residue. So the larger it is, the slower it takes to break down, and the smaller it is, about an inch or 2.5 centimeters, it'll help in breaking it down at a faster rate. And if you want it to break down heaps faster, make it smaller. That saves the bacteria and fungi more so just breaking it down faster. Moisture and temperature, you want a 60 to 80% for aerobic composting, 60 to 80. And when it's harvested, you want it about, I think it's 20 to 30% moisture retention. And the temperature, well, it's got to go above 70 degrees Celsius, which is the thermophilic range, to get rid of all the pathogens and seeds. And it's going to hold that for a few days. So there it's the thermophilic range. So if it gets into that range, it'll hold it for a few days and kill all the bad things inside of it. And that's one of the criterias. That's why you put it in big heaps. Maybe if you're in a colder environment, you might want to put it in a larger heap, and then you'll see it with snow on top, and it might have no snow on top because it'll be too warm. And then you'll get back to the mesophilic range, which is the microbes that we want, which is about 20 Celsius to 45 Celsius, I think. 50 Celsius, that's about their temperature range. And we want to retain and produce lots of them. So once all the bad ones are killed off, we can go back and let the process happen. What's this say? Shigella species, which cause designatory or E. coli common in sewage, are killed at 60 Celsius. Tapeworm and hookworm are killed at 55. Common pathogens are killed at 60. That's pretty cool. So that's, 60 is your 100 and... 60 F is 140 Fahrenheit. 55 is 130 Fahrenheit. Next principle is pH. Well, all right, most organisms grow under neutral pH. There will be a drop in pH due to the acid-forming bacteria, but pH will rise again due to formation of ammonia during the decomposition process. pH is auto-regulating in the composting process. It should be pretty much right, and you shouldn't have to worry about it. If you've got the right inputs, you shouldn't have to worry. If you've got a pH problem, if it's too low, look at your inputs. Microorganisms and the microbial inoculants are the key, lemon key. All right, I'll read this, then I'll give you my spiel. Mesophilic bacteria are involved in consuming readily degradable carbohydrates and proteins. Thermophilic bacteria attack lipids and hemicellulose. Actomycetes such as Thermospora cavata and many fungi involved in cellulose decomposition. Preparation, sawdust composition with inoculation of cellulitic fungi like Coprinus firmanus hasten the composting from 1 to 2 years to a few months. So they can speed it up. They're saying if you get the right microbes. So you're right. So really the plant material is made up of, well, lipids, but lots of cellulose, hemicellulose, and lignin. So you want to get ones that break down microbes that produce cellulase, which the ASE on the end is the enzyme version of that molecule, so it can degrade it. And if you get those right ones, like there's a lot of fungi that do it. So when you pick up your compost hole, after you might inoculate it before it rains, and then about 5 days later, it should have spread a bit. And then within a few weeks, you'll lift up the pile and there'll be dust. That dust is spores from fungi that have started to germinate and produce through your material to break it down. Then you'll see at the bottom of your compost are your grass clippings. What's that one pile? It's only probably 2 or 3 months old, and it's already formed clumps. It's aggregated together. So that's really, really good. It's just broken down super duper fast just by getting the right microbes. Number 7, the amendment with rock minerals. So if you want to put in a little bit extra, well, I'll read this first. Application of rock phosphate at 5% besides improving the phosphorus and nitrogen content also improves micronutrient content. Application of rock phosphorus with paddy straw along with inoculation of Aspergillus niger and Azotobacter coccum accelerates the process of composting and improves your NP content. Well, it improves your phloem and N content because this is a nitrogen fixing bacteria, and Aspergillus niger, it would be involved in breakdown of cellulase with phosphorus, producing at the end result at a guess. So I wouldn't really worry about this. If you've got a phosphorus problem, you can add the rock minerals and that'll give you an end result. But what is it? 40, what's the percent? 42%? 40 odd percent of your, after a crop has been harvested, 40 odd percent will be phosphorus remaining in the substrate. H2PO4 minus, the area, the one that you want. So I wouldn't worry too much about this. Factors, here's a rad summary. So the carbon and nitrogen ratio, you want 20, carbon is 20 to 30 is to 1. So 20 to 30, it's a little bit high. Particle size, this was a course that I did, actually. That's what I wanted to show you. If you want to go to my playlists here, these are all the courses that I've done, and they're all up there for free. So this course here, you can see a few are private because I'm doing this one at the moment. That's a rad course. Come on, where is it? I'll show you the ones for this one. So if you're wanting to go through, that entrepreneurship was a rad course. If you want to see some of the lectures that I didn't elaborate on, you might want to go here yourself. Botany's pretty good too. And you might come on, where is it? Oh, no way. It's here. I was just looking at the picture that time. Now look at the words. It's 43 lectures. I was looking at it before. It's from Kang Report. That doesn't matter, the university. There it is. So you can go to this playlist, you press the button like I did, and you come up with this. So it's had 45 views, that's cool. But this is all of the lectures. 6 years ago. Okay, that's a while ago. So today we're going to do these ones. 11 isn't even in. If you want 11, get on to me and I'll get onto the website and make sure that it's put here. Maybe I forgot that one. Oh, look, some bonus ones at the end. This course was written a few weeks ago, last year. So I'm currently doing it. What's that? How to catch mice with a pop can and a coating. Okay. Well, there you go. Anyway, I just wanted to prove, just to show you how to get to it if you'd like. And you can see it's listed as public. There's some more information fully about it. Cool, very good. Back to it. Should see if there's any questions actually. Good evening, Milligan Nuts. It's cool. So back to the properties of compost. What's the rad compost properties that's required? Particle size will be way smaller than that. This is factors of composting. Oh, composting. Okay, yeah. It's not compost like I thought it was talking about after it's composted. Moisture content, you want 60 to 80%. Lots of aeration. Temperature, well, high temperature in the first few days, you could just to get it into that thermophilic range, or at least get into that in one stage in the whole process, but it's better at the start, so I can kill all things at the start and they don't multiply. pH control is not necessary. Heap size, any length, 2.5 meters wide and 1.5 meters high. The reason why it's not going that size, like why wouldn't you think you put it massive? Because those people that make heaps that are giant, in the middle has no oxygen. So they're still doing a compost, but they're doing an anaerobic compost. So that's why you do it. It's activators use effective cellulotaphitic fungi or bacteria that produce cellulase or hemicellulase. Properties of good compost. So here's after it's been processed. So you wanted a nice dark rich color. You can go on that from Munsell's soil, Munsell's color chart, if you really want to get to detail about it. Poor quality, it will be a grey color and not smell good. So a good smell is an earthy smell, and the name of an earthy smell is geosmin, Geosmin. That's the terp that you get out of the good smelling, and it's good to know too. Bad odor, you'll go, oh, that smells a little bit off, because there's something bad's going on. Let the nose know. Good pH, 6.5 to 8 in the neutralish range for good quality. Poor quality, be out of that. Carbon to nitrogen ratio of an end result of 10:20. It'll be out of that for poor quality. Good temperature, moisture of 25:30. Humic acid, or the humus ratio must be high. In other words, a high amount of organic matter in it and a good amount of nitrogen. So that's why if it's broken down too fast, you won't get this high amount of nitrogen. Benefits of compost. I'm not going to talk about them. You all know the benefits. Pause it if you want to read it. That's it. 2. Vermicompost. What's vermis? Vermicompost. Well, vermis means worms in Latin, and it's a biotechnical process of composting, which uses earthworms. Earthworm. Oh, there's 3 types of earthworms: anaerobic, endozoic, and epizoic. Well, the anaerobic are the long, massive ones which tunnel vertical, which you don't want because they eat worm castings. So the endo and epi, endo means inside, so they're just underneath the soil. Epi means on the outside, so they're just underneath on the outside of the soil. You'll see them quite a lot in the O horizon, where the endos are in the A horizon. That'll do. Here's there you go. Epizoic, mean epi top, zoic is the earth. Endo means inside, and the sizes of them are small, only a few inches for on top, up to 4 inches or 12 to 10 centimeters in the A horizon or B horizon, and the ones you don't want are the massive ones, which are minimum of 8 centimeters to 15. There's a bit of a picture of them all. They might be used for fishing. Why vermicomposting? Well, you get the bonus of earthworms. A lot of aeration from it moving through. Flow of vermicastings. This is commercially producing it. You can see they make all their tents out of bamboo. That looks like wood, actually. Very cool. Waste characteristics. So if you want to know what's the carbon to nitrogen ratio of food, here's an example. I'm going to get a drink. while you read that page. There's 4 examples of that. So perfect is grass clippings. It's the right amount of green to the right amount of brown is the ratio that you're trying to get. The greener stuff is high in nitrogen and the browner stuff is high in carbon. So the mixing of waste and cow dung is very important because cow dung is a good inoculant. It has all the microbes in after reduction size. The thing about cow dung is in Australia, to get organic cow dung, the farmer is allowed to vaccinate it twice per year. Any more than that, any more than 2 injections, and it's not organic. Also, you've got of the produce of what it eats. So is it sourced from a field that the farmer might spray? That means it's going to have glyphosate on it or Roundup, and that's an antimicrobial. So consider where you get your cow dung from. And also, cow dung is a very low amount of NPK, so you might want to use other inoculants. But if you're using it just from microbes perspective, you might want to get it when it's a bit more runnier, because it'll still have live ones and they won't have the chance to have gone into spore form. So it might be more active. Here's how to, if you want to go into making vermicompost beds, here's some suggestions on how to do it, different layouts and things like that. So you can see there, 10 to 15 feet length, 4 foot wide, 1.5 depth. Here's some of the bamboo structures. Look at that, I love them. Split bamboo. Bamboo beds. Look at that, it's a big massive underneath thing. It's just so rad. So yeah, because look, remember you don't want sunlight, so to speak. So you want to retain the moisture. The sunlight's just going to dry it out. So that's why they're under covers. Here's some big commercial ones. A multi-tier vermicomposting beds. Look at that. Oh, they're so clever. Just with tarps over the top. Functions well. Look at this, a straw roof. It works well. Love it. Loads of waste mixtures in earthworms and beds. Loading of waste mixtures. Right, well, my suggestion is not to do it with beds, is to do it on the ground. So if you choose a good enough location, you'll draw the earthworms out of the ground and then they will do the work for you. You won't have to inoculate it, so to speak, which these people have to do. They've got to go and put all, so if you want to do it commercially, this is, you might want to read that, but this show's mostly not for commercial, so I'm not going to read it. Worm propagation in the mother beds, it's the same sort of thing. They want to get mother beds so they can dilute that with their worms. So they use it to multiply their worms in one bed, then they'll use little handfuls of those worms to inoculate other beds. Here's the technique how to do it. Excuse me. Vermicomposting accelerators. This is very important. The microbes multiplied in the laboratory is mixed with organic wastes thoroughly before putting in vermibeds. Some important fungus species are Paencillomyces fusosporus, Paean eroseti, Cryosporium, Trichoderma variety, and Bacillus polymyxa. Bacillus polymyxa is not fungus. I use it. It's bacteria. And it's awesome. It really is awesome. That one, it produces so many hormones as well as doing other jobs. It's not what we're talking about. Maintenance of moisture. Here we go. There you go. Remember I was kept on saying 60-80%? There you go. So when you're when these are functioning and doing their breakdown process, you must retain a high amount of moisture. Why is that? Well, because below 65% and there's no moisture for bacteria to grow. Actually, even Saccharomyces cerevisiae, that's one of a yeast that's 65% for its activity level to maintain. So if anything, you want that in the higher region, about 80. Bacteria are up about 85 to 90. So if you want it to maintain a really good process, stick to the higher number, not the lower one in that moisture content, and a good temperature. Went through the temperature before. If you can't control the moisture like these people, they've put in micro sprinklers. Material judgment. Oh, well, here's how to grade your vermicompost. On colour, particle size, pH, carbon and nitrogen ratio, nutrients, humus content, enzyme activity, and the microbial community. They're the whole things from grading it. Harvesting and separating your earthworms. A few different ways you can do. Heap it on the floor, and all earthworms will you put about 2 to 3 feet up to a metre, and then the earthworms will go down to the bottom. So you'll scoop off the top layer, and you'll put more, like another heap, and then wait a bit, and then they'll go down so you can scoop it off. That's one process, but it's time consuming. Or it's a mechanical process where you use sieves, and then you just shake it on the sieves. I think there's an example here. There it is. So there's a lady doing a manual sieve. Well, these are mechanical ones where they just put them on a rotator with a vibrator and an offset balance, and it spins and vibrates. And there you can see, look at that black. Yummy. That's so high quality. Jeez, it's nice just looking at that. That's such a brilliant amendment. Soil conditioner, when I used to make it, I'd give it to my favourite plants. Just really, really good. Dry cum sieving is another method if you're getting into commercial or industrial processes. Packaging. When you want to put the moisture is the most key thing. So about 25 to 30%. Conventionally, after separation of earthworms, the vermicompost is dried in natural process under sunlight. No, what does sunlight do? The UV might hurt something. Anyway, under cloudy conditions, particularly rainy season, open dry particularly comes difficult. All right. So there's a few drying methods you can dry it if you want. That's the end of that week. After drying, the vermicompost is bagged immediately by manual or mechanical, and the bag should be stored under cool conditions in the shade. Should we voters see if there are any questions? Take a second to hit the thumb. Thank you, GMF. I've been wanting to say that for a few shows now. I really appreciate that because the thumbs don't get really hit much. After the show, I'll hit the thumb button once, and it might be the only hit button. But, oh well. You know, I really naturally love doing this stuff, and the results that I'm getting are just amazingly fantastic. So my education and my experience has really paid off. So I love to share that with others so they can get the good results, organic results. Not go to the shop, spend top blimmin' dollar all the time and support the man who doesn't need to be supported. Genetic Memory Farm says, at what temperature, pH, and carbon nitrogen ratio do vermicompostants and regular compostants overlap? How warm can compost get before worms leave? Oh, hello, Monty. Nice to see you. Love the topic. Thank you for the nice words. When you Monty, 6 today. Excellent. 6 thumbs up. Thank you, peoples. Because I'm trying for a different approach. I'm not doing the other stuff that I used to do. I was getting backwards. I want to go forward with this plant science, soil science, and microbiology. It's just amazing. The stuff that I'm learning, I'm doing 2 microbe courses this semester and 1 plant crop breeding course. And it's just excellent. It gets me excited. Actually, I didn't tell this story yet. I was speaking to my professor the other night, the one in crop breeding, and he did a live for the class, and it was just me and him, and I was asking him all of these questions about breeding, and it was so excellent. He was getting excited too, and he was smiling and things. It was probably half an hour, me just rattling all of these technical questions about breeding. It was great fun. Just about how to manipulate chromosomes, about triploids and polyploids and stuff. It was, I love it. Back to the question. Generic Memory Farm says, chat, please make a comment video within minutes of the posting. That tells the algorithm that more people need to see this. Please and thank you. Oh, righto. So apparently, if you add a comment on this video within 15 minutes of it posting, that tells the algorithm that more people need to see it. Excellent, because I don't know about algorithms. I need to know those types of things. That's some really good info, thank you. Would it matter if I put up something too? I don't mind helping out. Monty, it's exciting stuff. Thanks, Monty. I love it too. Genetic Memory Farms after the video is over and posted, not live. Oh yeah, comments posted after the video help the algorithm. Thank you for clarification. We're up to lecture 15. Okay, so at what temperature, pH, and carbon to nitrogen ratio do vermicomposting and regular composting overlap? Let's have a look. Because the next lecture is on lecture 15. It's on enriched vermicompost production. So actually, let's go through that one first because that might answer that question. Yeah. And then if it doesn't answer the question, I'll go back. And look at that. It should be big screen. It should be that, eh? Or even without me, my picture there. Oh no. Oh, gee whiz. Or even like that. I do like having a little head in the corner though, but I wouldn't mind having my actual head. Because that might shovel up some words, but anyway, I'll get back to it. Soon I probably will have my little head, I reckon. You'll see me talking. What do you guys and girls think of the my logo on the top left? I adjusted the eyes. I couldn't find any good plants with one eye, so I could put one in each eye, because I'm not very good at this video stuff. Just another question. And back with, so remind me, Genetic Memory Farms, if this next lecture on lecture 15 doesn't answer your question, I'll come back and elaborate, and we'll try and find out the difference, please. All right, let's go. Last lecture. I'm up to 15. So enriched vermicompost production technology. So why would you want to enrich your vermicompost? Well, if you're getting outcomes that are lacking in certain minerals, you might want to enrich them. Other advantages, organic farming advantages, disadvantage of chemical farming. I'm not really getting into that. Stick to the topic. Why enrich vermicastings? Well, in general, the organic manures like farmyard manure, compost, vermicompost contain on the average 0.5 to 1.5 nitrogen, 0.2 to 0.8 P2O4 of potassium, and 0.5 to 1.2 of potassium. Let me read that again. 0.5 to 1.5 nitrogen, 0.2 to 0.8 of phosphorus, and 0.5 to 1.2 of potassium, which is not sufficient to meet crop demands in low doses. So for supplying nitrogen at 100 kilos per hectare, or like my garlic is about 80 kilos per hectare, the organic manure to be applied is 7 to 20 tonne, or what is it? I think it's 5 tonne per hectare of chicken manure. Oh no, that's a pH adjustment, sorry. This is talking about nitrogen. So yeah, it's got to be a lot higher. Because I grow green crops, and cycle them back through green manure and put it back through. So I don't have to care about my NPK ratio because mine's just champion. So I never have to enrich mine because I grow rotational crops and legumes out of season that I till back through to meet the demands amazingly. And then it's also microbially better as well. So I don't have to add anything. It's all just taking care of itself. Modification of vermicompost is either done by microbial enrichments or fortifying with nutrient-rich rock minerals or agricultural waste. Nutrient enrichment strategies from natural resources. So here's some organic inputs that you might use in your farm and agricultural and horticultural production. In gardening, to get good sources of nitrogen, here's the 5 or 6%. Groundnut is even 7%. That's very high. So if you look on the front NPK, typically of say a 5 to 5, mustard cake will meet 5. Phosphorus, well, rock phosphate, bone meal, 20 to 25%, basic slag. You don't know what's getting in that. Agricultural waste, the slag, the slurry, it might have pathogens. So it's good to put that through a full compost cycle before you're actually going to use it. That's what this is talking about, ways to enrich your vermicompost heaps. And potassium, you might want to use Silvite, which is a 63, wood ash, Casuarina wood, eucalyptus wood is a 5.9 of the ash of it. Bet you that's at different temperatures because the temperatures you burn at eliminate nutrients. Like if you have too hot of a fire, calcium goes at 1100 Celsius, as an example. Tobacco stem, other wool. Calcium and magnesium, you might want to use limestone, gypsum or dolomite. It's only $200 a ton. I know that seems like a lot, but if you want to amend a hectare, you're going to need tonnage. So it's surprisingly cheap. If you go to the store, you might be paying $20 for 10 kilos, where I'm paying $200 for 1,000 kilos. Enrichment, that's delivered too. And if you want to, what was the difference? Dolomite is both of these, Cal and Mag. Agricultural lime or limestone is just calcium. So consider that dolomite when you're doing this type of amendment. Also gives you magnesium in your substrate. Here's some different ways that they suggest to produce your vermicompost. So preparations, this is with cow dung, aquatic weeds as the green manure, and the brown manure is the agricultural wastes. They've gone and inoculated it with some rock phosphate, dolomite, and mica. Okay, they put in this ratio with earthworms and microbes, and these are the microbes over here: Trichoderma variety, Azococcus, Bacillus polymixa, Bacillus firmus, mix of the above. Mix of the above. Just use them all. I use about a dozen different microbes. I actually use that one and that one. I don't use that. I use Trichoderma hazarium, not variety, and maintain their numbers, so it's going to be high. What's this? This is a test that's been done showing the results of the effect of different organic wastes and microbial inoculants on organic carbon and nitrogen content in vermicompost. Right, so over here on the right, the microbial inoculation, it's got their little symbols at the end, and the organic wastes are the water hyacinth, paddy straw, and sawdust in those abbreviations. Excuse me. So over here we've got the control, which is up top, and you can see all these ones that are better, mostly below. Look at that. water hyacinth, it went down. So the control is better, as an example for using that, because Trichoderma variety, which is really a biopesticide, didn't give them the numbers they want, and it proved it here. I'm not going to, I've done a video on this. I break this right down. Do you want me to break it right down? You want me to go into detail? Tell me how things are going. I'll read to catch up a bit. Good. Pleasure, thanks. Oh, Monty says 7 words or more, otherwise the algorithm doesn't pick it up. Holy mackerel. Very interesting. I love this stuff. Because to try and put it into your search engine and get this information, good luck. Well, good luck to me. I'll spend ages trying to find stuff like that out. Roger. Monty says, good price for the lime delivered. Yeah, get Dolomite though. It's the same price. Get a mix, depends what you really want. Monty says, make sure your pH isn't. pH. Monty says, make sure your pH isn't going to spike, because Dolomite is sweet lime and can mess up the magnesium levels as well. Well, Dolomite's a mixture. It's 60% to about 30% calcium to magnesium, and your agricultural lime is about 96% calcium. So yeah, you'd use that in the right applications. But if you're seeing magnesium deficiency from your grass or other things like that, it wouldn't hurt getting some magnesium. But again, like Monty said, just make sure you do tests so you're not going to put things in excess. Hello, Sunshine RB. G'day, g'day, he says. Missed out on some good composting and vermicomposting up to the last lecture at the moment. Back into it. Oh, hang on, Monty says, I got my farm soil tested and soil is a little too acidic and magnesium is high, so I can't use Dolomite. Yes. Yes. Well said, Monty. And your soil's a little too acidic. Yes. So in that case, you'd be only using calcium for that reason, to not have a toxicity in magnesium. Nicely pointed out, Monty. Right, back to the last one. So this one is the effect of different organic wastes and microbial inoculants on phosphorus and potassium. So this one was just on carbon and nitrogen. And this is phosphorus and potassium. And you'll see over here, Polymyxa is a phosphorus solubilizing bacteria, and Firmus is a potassium solubilizing bacteria. So you expect those to be higher. Where Azos is a nitrogen fixing bacteria. Trichoderma variety, that's actually a biopesticide. Actually, what else does that? Am I sharing? Oh. So here the control up the top, and all these numbers are mostly higher. See, Azos is lower, which you'd expect because it's not producing any phosphorus. That's exactly right. So the rest are higher. Paddy straw and sawdust. Look how low the sawdust is, because it's pretty much got no nutritional value to start with. Paddy straw. What this summarizes is that the microbial inoculants help. Effect of rock minerals doses on microbial inoculation on earthworm growth rate. So these are three, the mica, the dolomite, and the rock phosphate. And you can see rock mineral dose percents on the x-axis, and the y-axis is the earthworm growth rate in milligrams per worm per day. So you can see it's pretty much up and down, isn't it? So I'd draw a conclusion that not much. Well, from knowing a bit about earthworms, this is just minerals, mica, rock phosphate. The earthworm's cycling organic matter. So unless it's highly out of balance, that's why it hasn't done anything. Effect of rock minerals, TOSAs, on total phosphorus content on vermicompost during composting process. This might be a bit of your question. Genetic memory farms. So days of vermicomposting, it's on the x-axis. Y is the phosphorus amount in milligrams per gram. Over rock minerals, the rock minerals were applied at 0 to 30% of organic wastes. It just shows it goes up a bit with the rock phosphate. So that's what it's saying, is that phosphate in there helps microbes or some sort of bacteria or fungi complete their process. They all need different enrichment cultures or their own, 5 things that a microbe needs to complete its process. Inorganic and organic materials, vitamins, electron acceptor, electron donor. So this comes under the mineral content. So it's just allowing that minerals in there at that particular time to do its thing. That's how I pull out of that. Dolomite didn't do much, and the mica didn't do much as well, but the phosphate did. Because it's, by the time it broke it down, might add a chemolithotroph to break it down and unleashed it, and then it could solubilize it. Effect on rock mineral doses on Olsen's. So it's a different way of testing your phosphorus. They had a higher ratio when it was tested differently under Olsen's way of testing. Effect on the total potassium wasn't much, but the mica did a lot. So there you go. So if you've got something that's a potassium pig, you might want to think about adding mica to your vermicompost or your compost. And as per this graph, it might improve it 3-4%. 3 or 4% in the outcome. If you've got an NPK that's jumped up 1 or 2%, that's humongous. Do you know that the NPK of cow manure is 0.5, 0.3, 0.5, something like that? It's under 1 for cow poo. Effects of rock mineral doses on ammonium, acetate, potassium content. Okay, so it goes up a bit. Mica goes up outstanding with the use of mica. Effect of rock mineral dose on biochemical properties. So urease activity and the acid phosphatase activity. So what's this? Urease activity went up with different minerals. It's all pretty balanced though, isn't it? So at the start, look, they're all the same, and as it goes, the days progress, it's pretty similar, I'd say, too. And acid phosphatase, it's pretty similar again. Changes in available NPK content of vermicompost during storage. This is a big one. So down the bottom, storage period goes up 3 months, 4 months, 5 months. So it peaks at 3 months. 4 months, it's back to what it was at the start. 5 months, it's below. So it looks like 4 months is your peak period for available nitrogen. Because what happens is this microbes, they start and break down. They use the nitrogen at the end here to complete their processes. So think about that use by date when you go and buy it from the shop, if you're not making your own. And testing the phosphorus continues to get enriched as things get broken down. Where's the control ? It's down here. What's that? Rock phosphate. That's RP. Okay. So as the rock phosphate gets broken down, that's why it keeps going up. All the other minerals are pretty similar. What's this one? DM15. It's dolomite 15. So that goes up as a bit. Maybe it wasn't supplied in powder form. The last one, storage period involving, should be potassium. It's gone up quite a bit from your mica, which said above as well. So if you want potassium, add some mica to your compost heaps. Very good. Take-home message: the water resources having low carbon enhance the growth and population of earthworms, thereby result of better quality of vermicompost with a result to chemical and biological ratio properties as compared to waste resources. You look at sawdust carbon nitrogen ratio, 366:1. So you can go and add some sawdust with some total green manure, but work your ratio out. So if that's 366, you might only add 1 kilo of this and 100 kilos of green manure, and it might work out. Combined applications of, I'll just stop sharing before I get into the microbes, fun bit. See if there's any questions. Oh, there is. Martial artist. G'day, martial artist. Molly says calcium was also low, so straight calcium lime is perfect remedy for my soil. Brilliant work. Nice to hear. Sunshine's, he's driving, but he's listening. That's the way, Sunshine. Driving and listening. Be careful. G'day. No, not here yet, unfortunately. Monty says, if you have soil that are 1.2 in NPK levels, 1 to 3% rising is humongous. Oh, yeah. Well, if cattle manure is 0.5, and that gives good results. Because remember, that's 1% of the total. If you're adding 1 kilo of compost and it's got a 1%, 1:1:1, that means 1% of that. So 1 kilo, so 100, 10 grams is nitrogen. Those NPK things mean. GMF says, so nitrogen drops after 3 to 4 months, but phosphorus keeps getting slowly more available. That's in the rock phosphate, mate, because it breaks down. And also the phosphorus is in a high content, comes out of microbial DNA. And if the microbes are there, they will they'll die, just their spores will remain if they're a spore producing microbe. Bacteria, and a lot of phosphorus comes from their DNA, backbone of their DNA. Monty says, let alone if you have soil NPK levels below 1%, a 1 to 3% rise is a difference between an awesome crop and a failed crop that ends up being grazed by animals. Oh yeah, yep, it's a massive difference. Green manure, growing crops and tilling them back in, I can say, is very advantageous. It's very easy, but it's, oh gosh. I've used, what do I use? 3 legumes and another type of green manure, buckwheat, and I'm just getting amazing results, like really, really good results. And I'm adding no inputs of phosphorus, nitrogen, nothing. It's just microbes and green manure, and irrigating at the right times and timing things at the right times. Sunshine RB says, how much for soil testing, Monty? Soil testing, to Monty. Rock phosphate comes from where? It comes out of rocks, believe it or not. Some rocks are particularly higher in it, and they just mine rock phosphate out straight out of the earth, like they mine from calcium, magnesium, stuff like that. Monty says his soil testing was 500. Holy mackerel. You can get it, samples done from the EPA, Environmental Protection Association, I think it is, in Australia. It's $80 a sample. But to do a soil test, you need to, from 1 hectare, it's supposed to be 20 spots, because you can't just go and get one spot. It's like when putting in a rain gauge. One rain gauge is different to what it is over there. It varies a lot because different nutrients cycle in the earth. You've got different things that have been tipped into the earth, killed it off, different microbes, different pollutants, all sorts of things. That's why you get different areas, different growth patterns in weeds or crops will also influence different outcomes, and they'll harbour different pathogens, which will give you like circles in your grass or just other sorts of, I fell off my chair then, other sorts of stuff that you don't want. So to do it properly, that's why it's so expensive, Sunshine, to do it. So if you were paying $80 a test for 20 tests, that's $1,600 per hectare to properly test your paddock or a 1 hectare paddock. My neighbour gets his tested. He gets 1 soil sample per kilometre and thinks it's all right, but that's how to properly do it anyway. I get taught the agricultural way. So there's many ways to do things, but that's just the way that it's done for agriculture. But it gives you, one test does give you an idea though. Monty says, yes, it was lots of little samples throughout each paddock. So you see, you're right on how the test is done. Oh yeah. Yeah, I went through that pretty much in this, that's in soil technology class, the first one that he's taught at Professor Chakraborty. He's done 5 soil classes that I've taken. And the very first one was on that, how to test properly, because I've gone over it quite a few times because I do soil testing myself. I perform it myself. pH is really good. Do the same sort of zigzag pattern with pH and get some results, and then do some amendments, and you see it's fantastic. I've done I pulled pH of 5.2, 5 to 5.2. I've got it up in a year. Fantastic. Everyone else around me is struggling, has to do all sorts of this and that. It's the techniques, when applied properly from my studies, have really worked well. It's really cool. Monty420 says, CC, you want to come down and have fun repairing the farm's soils, mate? Yeah, I love getting into that sort of stuff. It's great fun. It's just putting some on my education into and going back through slides to refresh my memory. But I'm more than willing to help. I don't mind. Hey, Jono, who cares? Holy mackerel. Hope you're doing well. Jono, who cares? Good morning, he says. Oh, Monty says, yeah, our pH on the farm was 5.2 to 5.8. Yep. Well, a few good techniques you can do to raise that. But he says it was that. See, so he's raised it as well. I've done a spreadsheet of every 3 months I took soil pH tests and did different things to amend it without using lime or calcium or magnesium. Didn't use any of that, and it worked within 12 months. Have we finished? Oh, that's right. Up to the last take-home message of this for today. Oh, Monty says aluminium is high. That's mega bad. Aluminium doesn't come from the ground or as an ore. So how is it so high on farm soil? Mate, it's mega. It's in the cation exchange. It hogs the bonding strength of the cation exchange. So if you go and put anything else into that, you've got to not any cation underneath it, aluminium can bump it off. So you're really struggling to get that out of the substrate. And it's a big no-no. Farmers have been using machinery or metal clippings, filings, all sorts of stuff like that. That's how I suggest. And you've had some sort of mining around where you are to get that, because it's got to be mined. And to get rid of it, there's microbes you can use. So you might have to go into some sort of bioremediation. I can talk to you about that another time. One of my courses this semester is microbial bioremediation. And I spoke to that professor a few weeks ago, actually. It was just me and him in the chat. So fun. I was on just me and him sitting in the chat room, just asking him questions as well. He's the one that helped me out with that glyphosate and taught me and sent all those papers to me. And I did that talk on that, how it's an antimicrobial. Australia doesn't know. Patented as an antimicrobial, glyphosate or Roundup is. So yeah, Monty, it's no good, mate. Anyway, read a few more. Jono, who cares? We have sand substrate, so I have no idea what I'm going to grow in it. Good luck. Monty says, I've been using JSF brews to repair our soil. Japanese something farming, Korean natural farming. No, it's not KR. So he's using some brews to repair a soil. No, it's good. I hope it works, mate. You've got to put the right, remember, it's about the right brew, about the right inoculants, and then you get the one that is. So what I'd do, I'd go and look up what's for bioremediation. You want bioaugmentation because you're going to be adding some microbes, and you want to see which microbe breaks down aluminium. So Google that, try and source that. That's where I'd start my search for. Then that aluminium will be turned into a more favorable element where it can be utilized and maybe broken down further, so it's out of your substrate and not in the way of the cation bonding strength. So it's hogging your cation bonding strength. It's terrible. Sunshine RB says, well, helicopters spray glyphosate out over large farms. That's how large farms get sprayed, mate. Then they use glyphosate-resistant strains of ryegrass or your other breads and wheats, and that's what we get dealt in Australia. So we're all getting nanoparticles of rye if you're not organic. I went through that in my talk a few weeks ago on glyphosate. I suggest everyone watch that, especially in Australia. It's a massive eye-opener. Australia has sequestered Google searches for results that I got from my professor in India. Monty says, aluminium isn't mined, CC. It's an alloy that's made from bauxite into Western Australia. Oh, yeah. I think the aluminium is being spread by planes. Oh, yes. Yeah, it's got to be spread somehow. It's no good. It's got to be in your ground somehow. I got no aluminium in my region, thank goodness. Genetic Memory Farm says microbes like Brachythrix thermus bradyca, Vibroangliocytitis, and Burkholder species can process and even remove aluminium from contaminated water and soil. Oh! And Burkholder species is a nitrogen-fixing bacteria too. So I'd be sourcing that if I was in Monty's shoes. Monty says, if your pH gets too high, aluminium becomes soluble and will be taken up by plants. Oh, yes, it will. Then will end up in us. Yes, it will. Yeah, plants are bioaccumulators. That's another way. That's called biophytoremediation, where you'll use plants. They'll plant plants in contaminated areas, like, for instance, your aluminium spot, and then they'll go and chop all the plants down and take them to another site and burn them or incinerate them at a toxic waste site. That's how they phytoremediate using plants. Monty says, can you send me that list? pH to low, sorry, acid. GMF says, sounds like some good organic matter will help those particular microbes cycle aluminium at a higher rate. Is this correct, Aussie? Well, you get different, like Bacillus subtilis. There's so many different species of that do so many things. It's actually used for humans now. Oh, not now, but it's been used in humans successfully. So they've got all different ones that used in agriculture, in humans, and they've tested them differently, and they're all species names. So Bacillus subtilis, species name N2378 or something like that. And that's the one that particularly does that particular role from the paper that you were reading. So to get any Bacillus subtilis and expect it to do the role that is in the paper that you're reading, it might not happen. So that's by getting strain-specific bacteria is relevant. Yeah. Because, from breeding, epigenetics. Microbes change. You can adapt them from into different conditions, which is similar to what their metabolic activity is, but they can just has different I don't know what the word I'm looking for. What does he say? Sounds like some good organic matter would help those particular microbes. Yes. So in general, organic matter, it's got all the stuff you want in it, a decent NPK ratio, and it's balanced, and it's at a good pH. So yes, I agree. Yes, getting some of those, I'd source some of those species. If I was in Monty's shoes, I'd be sourcing, well, the three that you suggest, I'd be looking up those and reading through papers on how people had successfully done that. And then I'd try and source those microbes. Being in Australia, that's exactly what I do. Next thing is good luck getting them. We're a friggin' island, and good luck getting it. And then when you speak to the bloody government, like I have, even the manager of the departments struggles. So, because Australia is new to organics, is what I've been told. And you'll go and look up, they've got an accepted list of microbes in Australia, and it's even got Bacillus cereus on it, which is good for food poisoning. So you don't need that as an example to has an import permit. Where those other ones, the three that are on the screen at the moment, you do definitely need that because they're not in the normal range. They're in bioremediation. Well, as far as I know, they're in bioremediation. Monty says that's why I've been making the micro brews, hoping that it would break down some of the aluminium. Yeah, you got to get source different cow slurry, get different sewage wastes, different sources of microbes that are very rich that you want to try and grab out of them. And then what will happen if you get that right Burkholderia, for instance, it might not be available in the air. Just like Saccharomyces cerevisiae is not available in the air. You've got to get an inoculant of it. So sourcing it somehow and unlocking that one little spore that you get and it germinates, bang, it'll start its process. So the greater wide variety of microbes that you can source that are relatively safe is what I'd do. I'd be looking at all sorts of manures, organic manures if I was you, because there's a high chance that you'll get some of that in it, that Burkholderia, or the other ones that, the other two I'm not familiar. I'm familiar with Burkholderia, but I'm not familiar with the other two that are on the screen. That were mentioned earlier. Monty says, I will be doing that for sure. TC, hopefully we can get it. Yeah. Sunshine RB says, nature provides, not corporations. Exactly. Yeah, if you're working well with organics, you got that right, Sunshine RB. Definitely blooming right. Maintain microbes, retain them, multiply them, let them work within your symbiosis. Monty says, I've got 3 barrels going with a different recipe in each. Hopefully we will find the right mix. 300 litre. Really? What's that? That's like 80-gallon barrels are brewing. Mate. Oh, mate. Did you know, too, that you might find out that some of those microbes might be facultative aerobes, meaning that they might work in low oxygen. So the Vibro and the Brocothrix, I'd look up those two genre and look up enrichment cultures on those particular ones on the screen now, and you'll see what their electron acceptor and donor and their micro and macronutrients that they require to get them cycling. So by getting the right enrichment culture, or the thing that these 3 need to complete their life cycle, you've got a higher chance if a spore comes in contact with it, if you give them the right substrate. GMF says, Monty, that sounds like the way to go. Well done. I couldn't say it any better. He's got 3 barrels he's trying to diverse his microbial population, the bioremediation techniques are excellent. It's fantastic. I hope you'd have oxygen in that. You'd have little air bubblers in there, wouldn't you, Monty? I hope. Because that'll speed everything up. And what that'll do, that will multiply the numbers. So instead of you getting a colony forming units of, say, 10 to the power of 2, you might get 10 to the power of 4. It might double the amount of microbes, or 10 to the power of 6. And also, you've also got to keep in mind their growth cycle, Monty. You can't multiply. You can't keep doing this for too long. You can't leave the barrel in there for 2 weeks because it's going to kill off the microbes. There's a growth. There's 4 phases in microbes. There's a lag phase, a log phase, a stationary, and a death phase. Should I do that? There's a lag phase at the start. Then it goes up to a log phase. This is their growth cycle. And then it's stationary at the top. And then it goes down in the death cycle. And these are in hours. So you can keep them going if they've got all the micro and macronutrients at the right time. My microbiology professor did a PhD and she kept them going for 9 months. As an example, I've kept them going for weeks. But I find after a period of a few days without the right elements that they're going to decline. So don't brew it for too long. And he says, yeah, a water pump and air stone. Okay, that's good. So I'd be considering that growth phase. So even a ppm meter, I know it's not accurate in the sense of it's not an optical density or a turbidity test, but at least it's something so you can know. Because if you're getting the elements that are staying the same, if you're putting in it saying 200 ppm and then next day it's 190, that's at a decline stage. So that means your brew needs adjusting to keep it going any longer, or you should have harvested before that date. So consider that, mate, because it's let me have a look. What else did you say? Hang on. GMF says, Monty, that sounds good. Well done. Monty says, today's topic has been so relevant for at the moment, and I've been given information by you boys. That has been great. Nice feedback, Monty. Thank you for the nice words. I'll see if I can share. I'll just look for it first. There's a in microbes. Yeah, I'll share the screen. So this is the experiment that I did. That's not what I want to see. I don't really want that there, to be honest. I just put it to describe. What was I looking for? Oh, that's right. All right, I'm sharing my screen now. Microbes. There's an assignment that I did on growth curves in compost in teas. I've got the brewing rate. I'll get in the bottom bit at the end. There it is. So here on the left, on the x-axis is the amount of hours. This was done in a 5-gallon bucket, 20-litre pail with oxygen, and it was compost teas and root teas. So a different varying amount of inputs, all organic. So it started on the y-axis. Here's the ppm. I used a ppm, just a digital TTS meter. So you see for the root tea, it went up within a few minutes, and then by 12 hours, it started to go up, then it stationary out. and then it kept going up again. So more nutrients were broken down, it kept going up, which is a very odd growth pattern. Over here on the right-hand side, you'll see the actual growth phase of microbes. So there's the lag, then the log, then stationary, and death. So you want to time it right so you're not in the death phase, Monty. You want to be harvesting at the stationary, and when the stationary is, that's when they're releasing most of their secondary metabolites at the end of the stationary death, at the stationary phase too. So it's very beneficial to maintain that phase. And you can see on the left here, I've tried to maintain that stationary phase as long as possible from just doing different things. And what's this conclusion? From 1 month doing worm extract tea that was leach-added out a catch bucket, my brews kept a stationary drift phase. Leachette was collecting over a 48-hour period. Next, I will try brewing the leachette. My concern is the new drops won't have enough time to oxygenate. Possibly anaerobic pathogens might stay in this state, which was true. I want 10 hours maintained with bubbles to rid any pest problems. I hope that helps. GMF says, AussieCC, are you familiar with Dr. Elaine Ingram? Yes, I am. And her development of a microbiometer to test bacterial fungi mass, as well as ratios in the soil for about $10 a test. Would a microbiometer help, Monty? There's a problem with the microbiometers. I found, I don't really want to talk about that. I don't want to. It's addressed to Monty anyway. If you want really a good cytometer is a good way under the microscope to look at and count your microbes. They've got a new one too. Oh, look how long I've been going for. We're just going into microbial testing on the other one. My microbial biotechnology class that was written last year. And that was I use a hemocytometer, which has, it looks like a slide that's, it's a slide that's got lines and patterns on it like grids. And they're so small you can't see them. But you put it under the microscope and you can see them all. And then you'll put your microbes under that end of that section and you can count them. And then there's a mass formula due to the colony forming units so you can work out approximately the biomass that you have. That's the way I support that one. Hey, Aussie Jeffro, how you going? Really appreciate the information, he says. I do love taking notes on different topics and issues that I can solve it hands-on. It's nice to kick back and listen. Thanks, CC and chat. No, thanks for your nice words, Aussie Jeffro. Genetic Memory Farm says, sorry, Aussie CC, I was just curious your thoughts. Not familiar with the microbiometer myself. All right. If it's the one I think it is, METER, you've asked my thoughts. This is one, it's a little tiny slide thing. Oh, hang on, this has got an app on it. So no, it's probably not the one I was thinking of. Download. Yeah, I'll share the screen. I'll put this in the description below. It's up top. Microbiome. I'm not familiar with that. Soil testing in the palm of your hand. About blooming time. Microbiomes. Low cost. 20 minutes for soil test for biomass of fungal and bacterial ratios. Really? Okay. Replaces costly. Yes. Give me some results. soil testing. Microbiome app stores all your information. There we go. $150. Oh, for 10 tests. So it's $15 a test. Or you buy a microscope and you can do it for free. $10 a test for the refills, or $9 a test. What's this? Microbiomes are very effective in time-saving field. It can be used by scientists, farmers, and gardeners in learning the microbial health of their soil. The microbial health, really? Why? That's because the microbial health is, in other words, if you've got really, so that's just going to tell you each individual, like a metagenomic study. So it's going to tell you which genus you've got in your substrate and how many of them. This testing process is also very non-invasive and thus having a lesser negative impact. That's not enough to convince me. I don't know. The app threw me off. This just could be people endorsing it. So yeah, I don't know anything about it. Here's someone in Australia has allowed us to quickly test existing benchmark measurements of our soil microbiology and reassesses the effective stock movements and plant soil amendments. I don't believe that. They've only got, let's go back to the screen on the app. Let's see, what's the test for? Let's zoom in on this. Oh, you can't see that, eh? All right, let's just zoom in like this. It won't let me do it. So what's it here? Soil results. Carbon per gram. So it's got a Munsell, so it's a color chart. Test. What are they testing for? What's this? pH? Is that pH? Yeah. I'd love to know what these things they're testing for, because you can get my soil professor tested, the one I was talking about before, Chakraborty. He was developing a test that you do, which you can currently get for free on an iPhone. I don't have an iPhone, but if you get an iPhone, I can give you that for free. It's the Munsell soil test, soil chart. It uses your camera to take a picture and puts it back through a reference grid like this to work out what color pattern it has to give a number. So I can't see how your microbial diversity is given from this screen. I definitely do not support this with my little basic amount of information that I have. I'll just add that bit too. That's my opinion. Sorry if that hurt people, but that's my opinion. Righto. It's an hour and a half. I only went through 5 of the lectures today. Well, it was still pretty good, wasn't it? So next week we'll be going from 16. Here I'll show you what add your words now. If you've got any words to put in, please, because we're going to be wrapping up very soon. Next week is vermicompost quality, introduction to pest disease management, and pest disease in organic farming, and a bit on pest diseases. Level C. There's 3 types, there's 3 levels of pest disease, and anyway, we'll go into that. Might go, to 5. Good, there's a bit of, I can go into detail about biopesticides with that heavily, so that's easily, those 5 lectures will run it through the hour easily, these 5. Because biopesticides, like you've seen today, certain microbes do certain tasks, and if you get the right microbe for the right task, you have won. That's that. It does the right job for you, and it's a microbe. You keep it alive, it does the right job for you forever, or for as long as you can maintain the spores and the active culture. Oh, GMF says, I'd love to see you do a series on testing and testing products, reviews, research, etc. You could do some killer product reviews. Just a thought. Nice thought, mate. Yes, I'd love to test some. I have tested a few things. Storks and Bickle were nice enough to send me some products. Actually, I can't really say that stuff because do you know you get taxed from that? I should have paid whatever. Monty says, wonder which companies would let him have their tests to be scrutinized. Yeah, I'd love to. I've gotten sent a few. Another person wanted me to test this grow blocks in a suitcase thing. And I said to him, I was just honest and said to him back, let's just have a video chat. I think this, so you got to do that. You got to do that. I just, just to save him sending, because he was starting off his business, and I appreciate people starting their business off, they don't have much money. So, but for big companies, I want a leaf porometer where it measures the CO2 coming out of a leaf. That's something that I've written and asked for, but that's $1,000 for that. I asked that company if I could test and review it. They didn't reply. But yeah, I'd like to, mate, because we need better ways to test our things, because at the moment we're kind of guessing, or we've got morphological expressions where we can use different morphological viewing, visual ways to identify different patterns. So, and the microscope. So I'm only at that. I'm not into the molecular level where we've got to use all sorts of electron scanning and fluorescence, GCMS, all these other fancy machines. It's like I haven't got any access to them, unfortunately. Monty says, I've got a copy of my soil tests. If you ever want a copy to use as an example to demonstrate, let me know, he says. Thank you for that, Monty. It would only be to help you, mate, because I've gone through even my neighbour's soil test, and it's just amazing. Like, well, there, for instance, stubble burning causes a 8 to 10% reduction in sulfur. He has an 8 to 10% reduction in sulfur. He also has a nitrogen problem, and stubble burning reduces 98% of your nitrogen. So this is one thing that instantly he can fix. So there's a few little practices that can be fixed to improve your substrates for the grounds. Look at the way that Mother Nature's done it right up until last 200 years, until we spoilt it. It's sad, isn't it? It's just sad. That's the one I want. That one you need to see bigger, don't you? What do you think of my little head there showing previously? I don't know if I should do it forever, but it's just something. Some people have it, and I just thought it looks nice. Because the reason why I was hiding before is because my last topic was controversial. I didn't want any problems. Monty says he would be better off tilling his stable back into the soil instead of burning it. Oh, mate, there's all sorts of problems there. More than that, he uses glyphosate. They use, anyway, I don't want to criticize people. It's just totally not my practices. Good farming practices, GFP, is what I maintain. He's done it. I know I want to talk about him. I want to talk about my show and bioremediation and improving our soils and our lands around us, so everything else can be better, in better health, which inevitably will help us in the long run. Helps us in hip pockets, helps us with disease. It's just so much. I'll go through this next week with the pesticides. It's so much by getting things on point and back working within themselves, cycling. There's so many profits. The ORAC, organic rating, improves. You've got a higher nutritional value. You've got a higher retention of microbes. Imagine all those microbes that we eat goes into us, all those endophytes, microbes that are inside of the plants. We put them back inside of us. We cycle them. Our bodies pick out which ones work better with us, eliminate cancers. There's all sorts of ones that really work really well. They've only 99% of the microbes are unculturable, so they don't know anything about them. So by us working with them, it's to one's advantage. The more I learn about the microbes, I've done, I think, must be nearly 10 microbe courses at university now. The more I learn about it, the more I'm learning that it is it's the winner. Microbes rule everything. I'm sort of rambling a bit here. Monty says, I've also got to find a remedy to the rushes in the paddocks. Really? I don't want to spray them good and burn them off. I've only just a Band-Aid solution. A good way to get them is pH. Some of them grow at lower pHs. So once you improve the pH, there's a rush grass that's around me that's called love grass. That's everybody sprays because it's a problem. Well, I'm not spraying. I'm doing other techniques. Of a good suggestion is to till at the right time of year, mate. I did that last season and I found none come up. Where if you till it summer, its roots go down to 9 meters, 27 feet in the ground. So by pulling it out at the top, it's good luck. It's going to come through. So you've got to get stuff to grow over the top of that, and then the earthworms to eat those roots and get rid of it. So to till at the right time of the year allows you to reseed. I reseeded legumes. They came up, and the little bit of love grass or the rush weed is struggling. It's out-competed. Well, it's not out-competed, it's struggling. And then I might till again because I'm going to end up tilling my whole fields for organic garlic. So I've kind of won. I didn't spray once. Monty says, so they're like acid. Yes, most weeds do. So applying lime and tilling them might fix it. I don't know, mate. I don't know what your circumstances or what type of rush weed you have. But for my rush weed, that's the approach that I'm tackling. Did you know also that putting it, here's another, and this works, tipping urine on it. Pee into a bottle, tip urine onto one of the weeds. So mow the grass, get it low, and you'll see it starting to sprout again. Tip urine onto it. Do it daily for 7 days. By the 7th day, you've created it in saline conditions. The salts is too high for it to grow. It's kind of like us in no oxygen. We can't breathe. So it's a good way to suffocate a plant or a tree is by salting it, saline conditions. And urine's a good way because it's not harmful putting sodium into your substrate. It's putting urine, which can cycle. Sunshine says, on the freeway, tripping ass on espresso. Hey, go Sunshine! Monty says, I think they're bulrush. Oh. Well, check out the pH range of your rush weed, mate. Your bulrush. I'll put it in. pH of bulrush. Bulrush can tolerate a wide range of pHs, thriving in acid, neutral, or alkaline. Uh-oh. Well, that's not very good, is it? I'll see what it says. How to rid bulrush. Combination of manual removal, mechanical excavation, and chemical control. So it's good luck. Wow. So it's not a pH thing. You can't just go and do that one. Unfortunately, you might be into the tilling. So till, reseed with your favourable legumes or whatever you want to. You might use clover as a cover crop and sun hemp or buckwheat as a mature size crop, one that grows 1 metre to 2 metres tall. And then once you put them out, they'll keep cycling. And then if it's too much every 12 months, you might want to till again, or every 6 months, or at the start of the spring, at the end of spring, for instance. Try and time it right in the growing period of the legumes, and then you might outcompete your bulrush and find that you can do it that way, mate. Add a suggestion. Well, put in stuff in the chat now. This has been going for 1 hour and 40. Holy mackerel. Monty says, damn, sounds like tilling and sowing at the right time of year will win the battle. It could possibly. Well, everyone around here swears about love grass. They can't get rid of it. They just can't. They swear they got helicopters spraying around for spraying it as well as big, massive trucks with booms. And I'm dealing with it too, and that's how I've dealt with it. So it's only been 12 months. So see how it goes, but I'm winning the battle. Monty says, I've been told this time of year is the time to attack the rushes. Yes, coming into, well, you'd have to look up their growth cycle. So look up, is it a long day plant? Is it a short day plant? When does it and a lot of these things will be for northern hemispheres, so you've got to go and convert it to the southern hemisphere, make it 6 months apart. By finding out its exact growth conditions, you can work with that, mate. And yes, like genetic memory farms is possibly get some sort of animal that likes to eat it too. I know that the love grass is very thin, just maybe like your rush grass, is very thin leaves, and they aren't real healthy, not much nutritional value, and therefore the animals aren't real favourable towards it. That's the case with this love grass, unfortunately, even though some countries do grow it, but you've got to keep it short to keep it nutritional value. It's good drought resistance because of its long length of its roots. We've been going for ages. All right, hold your thoughts until next week. Monty, let me know about your rush after you've looked up more of your rush weed, your bull rush weed. Let's talk about it more next week. This has been pretty cool. I like helping people fault find things. I'm into plant pathology and organic practices to remediate things. So, yeah, and the reason being because my education has got me to the stage where I can put all the stuff together and go, oh, this might cause this problem if you do this. Oh, hang on, this might have a counteractive problem for this. Like Mulder's antagonistic wheel. That's an example. Like this thing, MUL. This thing. I'll have to put it in the chat. Because things can a lot of things won't work with the other. So by knowing the right things, it really helps. Look at the smoking man. So see how this, if you put zinc in, zinc with iron might antagonize it, where molybdenum, where's another example? Molybdenum stimulates it. So to know all this is hard. So by me, with my education, I've got enough done now so that I can fault find things, and I enjoy that side of it. To be honest, the only paddocks I see, Monty says, with no rushes are paddocks used for cropping, and I bet they're using chemicals. I bet you're correct. Monty says goats would for sure, Jimmy. There you go. Sheep, cows, horses won't eat it, but goats. Well, you know about goats too, they only, because I got goats, and they only graze. They say if you want an animal to eat one particular grass, get sheep. But goats will only eat a bit of this, a bit of that, bit of that. They won't, like blackberry bush. They say goats love that. Well, they do, but they're selective eaters. They'll eat a little bit of this, then a little bit of that. They don't pig out on one thing, from what I've found. But yeah, at least you've got some now type of mechanical way to approach it. Get some goats, mate. Miniature goats. They're rad fun. And look at its growth cycle, and then get back to me next week. And I'm sure between me and other cool members in the chat, we'll have some good suggestions for you to try again. This has been fun as this show. Thank you, everybody, for contributing. I can't believe it's nearly 2 hours. I only like to go for an hour. I only did 5 lectures. Holy mackerel. It's good, though. Appreciate everyone listening and helping and contributing. It's great fun. So let's do this again next week. Hopefully we can have the same amount of fun again. And hit the thumbs up and like. Write more than 7 words after the in the chat afterwards. That's to help the algorithms. Thank you, everybody. Leave a chat. More than 7 words. Yes, we've just learnt today. I've learnt a few things actually about the I just love continuously learning. Chat teaches me, I help them. What a lovely symbiotic circle this is. Happy breeding, happy growing, good health to everybody. I hope you turn up, and I'll see you all next week. Thank you again. Bye-bye.